In this video, we're going to talk about angles and arcs inside of circles. And we're going to define what those things are and then look at a couple examples, different types of arcs, and then how to measure arcs inside of a circle. But before we get to arcs, we need to start with angles. And there are several different types of angles inside of a circle. The one we're going to talk about today we call the central angle. And a central angle, just like its name suggests, is an angle and the center of the circle, and specifically an angle whose vertex is the center of the circle. So if we look at this picture here, we have circle K. A circle, of course, we name it by the center point, so circle K. And then the vertex of the angle has to be that center point K. So here we have angle EKF. That's a central angle. The center of the circle is the vertex of the angle. And typically, the two sides of the angle are formed by radii of the circle. Radii being two radiuses. Radii is the plural of radius. So we have EK is a radius, FK is a radius. So we have this central angle here. And that's what a central angle is. An arc of a circle is just part of a circle. And it says here, part of a circle defined by two endpoints. Meaning, when we talk about part of a circle, we have to know where to start and where to stop on the circle. An important thing for us to remember is that when we talk about a circle, the circle is actually just this curvy line around the outside. That's what the circle is. There's all this space, this area inside, which we would call the interior of the circle, and there's, of course, the center point in there. But the circle, when we say the circle, we're talking about just this curvy line. So part of the circle is just this sort of curvy line around out here. When we measure around the circle, when we talk about the circumference of the circle, we're really talking about sort of the length all the way around the circle. And later we'll talk about how to actually find the length of just part of this arc, what we would call the arc length. Here we're going to talk about the arc measure. So two things for you to make sure you keep straight. The arc measure versus the arc length. The arc measure is just the measure of the central angle that creates the arc. And because you measure an angle in degrees, you measure an arc in degrees. Now, in your class, you might measure angles in something called radians. If that's you, then you can measure arcs in radians as well. But the measure of an arc is the same as the measure of the angle that creates that arc. Notice how arc, and here we should say, when you talk about an arc, we name the arc sort of like we would name a line segment. So here we have arc FE. But instead of having to write out arc, we just say, okay, we have FE, and it's an arc, so I'm going to put this arc over the top of it. Just like when you have a line segment, you have the two endpoints and you put a line segment over the top of it. Here we have the two endpoints and we put an arc over the top of it. So, to talk about the measure of arc FE, we just need to know the measure of the angle here that created that arc. So if angle EKF has a measure of 67.52 degrees, then arc FE has a measure of 67.52 degrees. Another thing to point out here is that here I called this arc FE. You could also call it arc EF. That wouldn't change anything. You might wonder, well, what about the other part of the circle? We've sort of cut it into two parts. There's FE and then there's the rest. We'll talk about the rest of that in just a second. But for now, we have arc measure is the same as the measure of the central angle. Now there are different types of arcs. The first type of arc is what we call a minor arc. And a minor arc is an arc with a measure less than 180 degrees. So here's an example of that. This arc has a measure of less than 180 degrees. It's the same arc that we talked about in the last one, where we said that the measure of this arc FE was 67.52 degrees. And we can just kind of see, for the most part, that this is obviously less than 180 degrees. 180 degrees would be half the circle. This is much less than half the circle. So when it's less than half the circle, we call it a minor arc. When the arc is exactly half the circle, we call that a semicircle. And hopefully you remember that. Half a circle is called a semicircle. And really, a semicircle is just a special type of arc. It's an arc where the measure is exactly 180 degrees. So when you talk about a semicircle, because it's half the circle, there's two halves of the circle. And so here we have semicircle F. Oops, I wrote G here, but I meant J, didn't I? Let's change that. So we have F, J, E, that arc, or arc F, H, E. By putting the, I can see when I look at this that arc FE is going to be half the circle, but I don't know which half. Do I mean the right half, or do I mean the left half? And so putting this letter in the middle, either the J or the H, that tells the reader which half do you mean. And sort of what I like to think about is that you need to go in the order that the letters are listed. So start at F, go to J, then go to E. That tells me it's going to be this right half. Go in that order, F to J to E. Or start from F, go to H, then to E. So that letter in the middle just sort of tells me which side I'm going to work with here. And then we have one more type of arc, and this is a major arc. And a major arc is an arc with measure more than 180 degrees. So if you remember, we had a minor arc, the measure was less than 180, a semicircle, the measure is 180, and now a major arc, it's more than 180. And just like for a semicircle, we need 3 points here. And the 3 points, for the same reason, tell me which direction to go. When we looked at minor arcs, we had just arc FE, just between F and E. But now I put this L in the middle to tell the reader that you've got to go from F to L to E. And so sort of the rule for arcs is always go the short distance between the 2 points if you can. So if there's only 2 points, it's always the shortest distance. So EF or FE would just be this short distance here. But then when I have a third letter, that tells me, okay, I've got to hit all these letters in this order. So I've got to go from F to L to E. So that tells me that I'm doing this big outside arc here from F to L to E. So now that we know what the different types of arcs are and how to measure them, let's look at a quick example. Okay, so in this example, it says we have circle P, so the center is P. The measure of angle NPM is 46, so I'm going to put a little 46 right in there. PL bisects angle KPM, so I'm going to show that these two pieces are congruent. Put my little congruent arcs there. And OP and KN are perpendicular. So OP and KN is going to be a right angle right there. And now it wants me to find the measure of a couple of different arcs here. So when I look here, it wants to know the measure of arc OK. So to do that, I'm just going to look at, all right, here's arc OK. Start on O, go trace around the outside to K. And what we said before was that the measure of the arc is equal to the measure of the angle. So I need to know what's the measure of arc, or what's the measure of angle OPK. that central angle, since P is the center, has the same measure as the arc. And if we think about it, because OPN is a right angle, OPK also must be a right angle. So that means that's a 90-degree angle, which means that the measure of arc OK is equal to 90 degrees. Not too bad, not too bad. Now we need to know what's the measure of arc LM. So now we're over here on the right side. And again, this is a minor arc because there's just 2 letters. So I know I'm just going to go from L straight to M, the shortest distance from L to M. Not going to go around this crazy way to make a major arc because there's only 2 letters. They didn't tell me I had to go the long way, so I go the short way from L to M. Now here they didn't give me the angle measure, but we can figure it out. If this is 46, the whole thing is a straight line, that leaves, if we do a little quick math here, 180 minus 46 leaves me with 134. So the whole rest of this angle, angle KPM, needs to be 134, and because PL bisects that angle, I know that I can just cut that in half. So we'll do 134 divided by 2, which is going to be 67. And so each of these little angles here is 67. So each of those central angles is 67 degrees, and we know that whatever the measure of the central angle is, P is the vertex, or P is the center, so it's a central angle. The arc has the same measure. So then we can say that the measure of arc LM is 67 degrees. All right. So now to the last part. Now we need to know arc JKO. I have to go in that order, from J to K to O. So this would be a major arc, much more than halfway around the circle. In fact, it's just this little piece here, angle JPO, that we're missing. So if we look at this, one way I can think about this is if I can just find JPO, find that angle, then I can subtract that from 360 and get the whole rest of the circle. So that's what we're going to do here. And there's going to be sort of 2 steps to doing that. First, I see that angle MPN and angle KPJ are vertical angles, so this is also 40. Oops, wrong button. So this is also 46 degrees here. And so then if this is 46, if KPJ is 46 and KPO is 90, if I do a little bit of quick math here, 90 minus 46 leaves me with 44, sorry. So that means this little angle is 44. I want the whole rest of the circle besides that 44. So I do 360 minus 44, and I get 316. So the whole way around the circle, from J to K all the way to O, that arc has a measure of 316 degrees. So, so the measure of arc JKO is 316 degrees. And that is what we need to know about arcs, central angles, and arc measures. Central angle, an angle with the vertex at the center. Arc, part of a circle, which is just the outside of the circle. We have minor arcs, which are less than 180, semicircles, which equal 180, and then major arcs, which go more than 180. And then to find the measure of an arc, you just look at the measure of the central angle. And sometimes you've got to do a little bit of work, use what you know about angles to find those measurements. But that is all for central angles, arcs, and arc measures.